Another thing we wanted to look at with the parametrics was the movement of the unit circle. So the unit circle, of course, was defined parametrically as x equals the cosine uh, of variable, comma, the sine, comma, I don't know why that's doing that. Okay, comma, the sine of the variable, and okay. Now, of course, the variable here, t, is actually representing the angle, which needs to kick up to 2 pi. You can't put pi in there. You're going to have to put the decimal, 6.28. Okay, so that's that. We could enlarge that a little bit. Of course, that is static. That is not actually showing the motion, so you're not appreciating the dynamics of the parametric equation. So what we're going to do here is, we're going to duplicate this. Okay, we're going to change this to a variable, uh, and then we're going to look at it from a parametric standpoint. Okay, so slider on A, again, that's going to go from 0 to 6.28. Okay, step is continuous. We leave it at that. Okay, let's just dress this up, I guess, to maybe have dotted path, and then we'll follow the motion of the circle. Okay, so here we go. That's that. This is going to be now done. We're done with that. Okay, this is going just one direction, and of course, this is the movement of the around the unit circle clockwise. As you can see where we're starting and where we're going. Okay, now some alterations on that. Okay, will show you a little deviation from the unit circle. Okay, so this is following the unit circle, but a few slight little alterations on that, you might see what will happen. First off, if I wanted to change the direction, if I put the negative in front of here, you see what's happening. I've changed the direction, okay? And you should ask yourself why that is doing that. And that was because basically I determined that the first point that I was going to plot was going to be right here. The second point was going to be right here. And that was just altered with that sign, okay? But, more dramatically would be things like uh, putting some coefficients in front here. And if you could see now that the path is moved away from that of a unit circle, and if I wanted to see the path it was taking, I'd make that up here, and that's the path of an ellipse, okay? I can make some kind of interesting changes here by changing some values in here. If I were to put 2 in there, look at the path, look at the change of the path now. Okay, and of course you can see it's not the path there, but if I wanted to see the path it was generating, I would just go and I would put my 2 in here, and that would indicate the path that it's taken there. So this is called a lemniscate, the path that's generating there. Some of which we will discuss, some will be discussed perhaps in future classes. But it's just interesting, okay? It gives you a little something to play with, okay? And I suggest that you do that. Of course, questions that you need to ask yourself is, can we turn this into an equation in x and y by eliminating the parameter? And of course, we will address some of that down the line. But for now, I suggest take a look, play with this Desmos, get a better understanding of the path that these things follow. Okay, just by playing around with it, and get an appreciation for what parametric equations can do for us. Okay, so play with it at your discretion. I'd suggest that you create an account so that you have these files that you can save and pull up and study from for future reference. Okay, so that'll do it for now.